Right, so we're going to start with number 2. Number 2 is find the solution to the differential equation given by this. It's just a Q instead of a Y. It's just a different letter of the alphabet, so don't let that bother you. And then the initial condition is 0, 7. So we're going to start by separating the variables. We're going to divide over the Q. It'll be 1 over Q dQ. And then multiply over the dt. So that's 0.05 dt. And then antiderivative. So on the left side, we're going to get ln of q. And on the right side, we're going to put 0.05 t plus c. And t is your variable. So if you have just a number here, that's the coefficient in front of t. The derivative of 0.05 t would be just 0.05. All right, then we're going to plug in our initial condition. So if you plug in 0 for t, that's just all going to be gone. And then 7 for q. So c is ln of 7. I did not line that up very well. Let me fix that. This looks funny. So ln of 7 is our c value. And then we're going to recopy this step. I'll come over here to have enough space. And instead of plus c, we're going to put plus ln of 7. And then we're going to exponentiate both sides to get q by itself. So it's e to the power of. Now e and ln will cancel out. That 7 is just going to be written out front as a coefficient. So it's 7e to the power 0.05 t. When you drop the absolute value, you would put plus and minus for the general solution. We're doing just the positive because this initial condition is a positive 7. So that is our answer for that one. All right, number 3, a particle begins at 2, 1. That's the initial condition. X is 2, y is 1. Moves along the y-axis so that at time t, its velocity, y prime, is quadruple the position y. Okay, that's a lot to read through there. But velocity y prime, all right, that's the derivative. Velocity is a derivative. Instead of y prime, though, you want to write dy dt for the differential equation. So y prime, we're going to write that as dy dt, and it says that that is quadruple the position y. So that would be 4y. And then we're going to separate the variables. So divide over the y, multiply over the dt, and then antiderivative. And so we get ln of y equals 4t plus c. And we're going to plug in our initial condition. So t is 2, so 4 times 2 would be 8. And y is 1. ln of 1 would be 0. And so we get c is -8. So I'm going to recopy this step, except instead of plus c, I'm going to put -8. And then to get y by itself, we're going to exponentiate. So it'll be e to the power of all of this. And again, when you drop the absolute value, you would put plus and minus, but our initial condition is positive. So we're just going to do the positive version of that. All right, what else, guys? Don't take too long to tell me what you want, because that cuts into the amount of time we have to go over these. All right, 10. All right, so we're going to draw the slope field for all those points that are indicated there. And then we're going to describe what the solutions look like. So just in general, just basically what's going on. Now, this is going to be a little bit tedious to draw out. The one I put on your test isn't quite so involved. I always try to make the study guide harder than the test. So like if you can do the study guide, the test will be easier, by comparison. I want to find all the 0 slopes first. Anywhere that x is 0, we're going to have a 0 slope. So I can put in zeros for this entire column here. All right, and anywhere that y is -1, we're also going to have 0. If you plug in -1 for y, that's going to make this 0. So these are also all going to be 0. So you can knock out a whole bunch of it just by looking for the 0 slopes. And then there's a certain amount of this that is going to, reflect. Notice we have the y cubed over here. On this side, all the x's are negative. On this side, all the x's are positive. So once we get this half, we can take that and reflect it over. So we're really going to just need to do these points over here, right? So here we have -2, 2. If we plug in -2 for x, gosh, that would make that -8. 2 for y, that would be 3 squared, which is 9. -8 times 9, that would be -72. Okay, that is like practically vertical. It's so negative. So very, very, very steeply negative. And again, they just have to make sense in relation to each other. All right, so here we've got -2, 1. So that would be -8 again for this part. 1 plus 1 is 2, squared is 4. -8 times 4, that would be -32, which is still very, very steep, but maybe just not quite as much as -72. All right, -2, 0 will be -8 times 1, which would just be -8. So again, a little bit less than the one before. So they're getting less and less steep here. All right, and then this is -2, -2. So if we plug in -2 for y, plus 1 would be -1, squared would be +1. So again, that's a -8 slope. So that should look the same as this one, close as you can make it. And then -2, -3, the same thing is going to happen as did here. So I'm going to try and make it look the same as that. So it's like a little bit more steep. Again, just in relationship to each other, they have to make sense. All right, for this whole column, x is -1, which is just going to make this negative out front. So I really kind of just need to worry about the y's. Y is 2 here. So 2 plus 1 would be 3, squared is 9. I want it to be -9, which I think this one was -8. So -9 would look about the same as that one. All right, for here, y is 1. 1 plus 1 is 2, squared is 4. We want to make it negative. So -4 is the least steep one that we've gotten so far. And then here, y is 0, plus 1 would be 1, squared is 1. So -1, which is, these are getting less and less steep here. Let me fix this one. That should be kind of like in between those two. And it's not going to be perfect. I always tell you guys that, and then here I am trying to make it perfect. You can't make it perfect. It's going to be good enough. All right, here y is -2. Once we square that, that's going to be a +1, but we're going to make it negative. So -1. And then this one's going to be the same as this one again. So like a little bit more steep. All right, good enough. Now I'm going to take all of those and reflect them over here. Because again, x is negative over here, but it's positive over here. So I'm going to take those and just reflect them over. This was the one that was like practically vertical here. They're pretty good. And again, the one I put on the test doesn't have as many points on it. Again, I try to make the test harder. So I try to make the study guide harder than the test. So the test would be easier in comparison. I've drawn all those slopes on there. That's good enough. Use the slope field to briefly, I don't want an essay here, okay? Describe the solutions. So pick like one characteristic to look at. See this? We have a horizontal asymptote at y equals -1. So let's just say that. Horizontal asymptote at y equals -1. All right, good enough for that. I don't want like a whole lot there. Just, tell me something that's going on with it. Number 4 next. Let me go back to number 4. So number 4 just says, write this differential equation in separable form. So basically it's the same as what we did in questions 2 and 3, but just don't go through the whole process. All I want you to do is separate them. Now, in order to get y, moved over, we would have to factor y out of this though. So there's one step where we're going to have to factor out the y. So if you divide out y, you'd be left with x plus 1. And then to separate this, you would divide over the y and then multiply over the dx. And then that's it. We've separated it. You don't need to go any further. It's just separate the variables. So basically just do like the first step of the problem. All right, what else would you guys like? Let's see what else we've got here. Do you want to pick any of the ones on this page? We haven't done any there. 9. All right. So the slope field for this differential equation, and then there's a whole bunch of things describing it here. Here's what I would do. I would draw a quick sketch of the slope field, and I don't go very far. I would just go, from -2 to +2. This one's going to be quick to sketch because it only has x, so all the columns are going to be the same. So for this whole column, x is -2. So the slope would be -2. So let me do like a -2 slope for this whole column. And then for this whole column, x is -1. That would be like not quite as steep. And then here, x is 0. And then +1. And then +2. So a little bit steeper than that. So it only takes a second just to draw real quick. And so you can see you're ending up with, parabola kind of shaped things. And if you were to work this out, this antiderivative would be 1/2 x squared. So that makes sense. You're ending up with these parabolas. All right, so out of these choices, let's see which one makes sense here. Has line segments, these are all our little line segments here, these slopes, symmetric to the y-axis. That's actually the one that's true. This is going to be A. If I take what's over here, it reflects over here. So they're symmetric to the y-axis. We can look at the other ones and show why they're not true, though. Says the solutions to the differential equation are cubic. No, these look quadratic. So they're not cubic. Shows that they are straight lines. No, they are quadratic. They're U-shapes. Shows that the solutions are decreasing for increasing x. All right, that means as x gets bigger, y gets smaller. But that's not what's happening. As x gets bigger, these slopes are going up. So not D. And shows that there's a horizontal asymptote. No. For there to be a horizontal asymptote, you have to have a situation like this where you get 0 slopes the whole way across. All right, number 12. All right, good. I'm glad you guys asked about one of the calculator ones. So you have to make sure you know how to use your calculator to do these questions. You have to be able to store. I can't give you full credit. I'll give you partial credit, but I can't give you full credit if your final answer isn't accurate to 3 places. So just make sure that you can do that. On the AP exam, they'll give you nothing, right? So be friends with your calculator. So this element has a half-life of 50 years. So 50 years is the time, and that means you end up with half of what you started with. 700 grams present initially. Oh, and I even told you what a half-life is. That's not going to say that on the test, right? So here's our equation. And we're starting with 700. Our time is 50 years. And if you start with 700 and it's a half-life, you have half of that left, which would be 350. But like we did in the homework, you can actually skip this step because if it's a half-life, when you divide that over, you're going to get a half. So you actually don't even need to know either of those numbers. They could be unknown, again, like the ones we did in the homework. It's going to be a half if it's a half-life. So we will ln both sides. And then we're going to divide by 50. So we are going to type in ln of a half, close parenthesis, divided by 50. We get negative. Oh, why is the rate negative, guys? How come we got a negative rate? Let me throw that question to you. Why is the rate negative? Yeah, perfect. The amount of this element that you have is decreasing. It's degrading, right? So you're having less and less. Again, this is my favorite sticker. If your amount is increasing, your rate is positive. If your amount is decreasing, your rate is negative. Right, so it makes sense that that's negative. I'm going to store it. So store alpha A, enter, negative 0.013. All right, so that's what I'm writing on my paper, but I have it stored in the calculator. So it says, what is A? Write an equation. All right, so your equation is y equals 700. That was the initial amount, e to the power negative 0.013t. And it says round to 3 decimal points. You can truncate though. Again, just take the first 3 that you see. That's our equation. So don't just stop here when you get K. Make sure you actually follow through and write the final answer. How many grams remain after 300 years? all you've got to do is plug in 300 to t and just make sure you use your stored value. So 700 e to the power alpha a times 300. And so we have 10.937 grams. And make sure you put units. I'll just write that whole decimal because it only goes one decimal point further. 10.9375 grams. So you started with 700 grams. 300 years go by, all you have left is 10. And then this one, use that same equation to predict the amount after 74 years. All right, you're just going to plug in 74. So let me just go back and bring this back so I don't have to type it all again. And I'm going to change the 300 to 74. So if only 74 years have gone by, we would expect to have more of the elements still left. So you should get a number bigger than 10. It's a lot bigger than 10. So, but less than 700. We started with 700. So after 74 years, we've got 250.942 pounds. All right, let's see how much of this is left. I don't want to do the whole thing for you because I want there to still be some for you to try for practice. Maybe do you guys want to pick one or two on this page? Why don't we do, well, you know, let's do 5 and 7 or 6 because you picked the one that I didn't pick. All right, let's do 6. So you would multiply over the dx in order to separate that. And then antiderivative. Now, what's really nice about this one is it's going to be y equals, which is fantastic. And this antiderivative would be 1/3 x cubed minus 3/2 x squared plus c. And there is no initial condition given, so you're going to just leave it with the plus c in there. If you don't have an initial condition, it's just the general solution. So you would just leave it like that. All right, why don't you guys pick 5 or 7? Let me do one or the other. Again, I don't want to do every single one because I want you guys to have some to still practice. All right, let's do 7. All right, so to separate this, you would divide over the y squared. So it'll be y to the -2 dy, and then multiply over the dx. And if you want to put a 1 in there, you can. Like over here, you can put a 1 in front of the dy if that helps you. So antiderivative, we're going to add 1 to the power, makes it less negative, and then we divide by a -1. So that'll put a negative out. This antiderivative will just be x and then plus c. Now, before you plug this in, I think it's a good idea to fix the negative exponent. It's just easier to plug in numbers if you don't have that. This would be -1 over y equals x plus c. All right, so we're going to plug in 0 for x. I'll make that just be c. 2 for y. And so c is -1/2. And so I'm going to recopy this line and put in that -1/2 for c. And then last step is solve for y. So what is going to happen is you're going to multiply over this y, divide over this x minus 1/2. So those two items are going to switch places. And then y is by itself, so we're done. Now, if the y was to a power, like the one in the homework we did, it was like a y squared, then you had to square root. But this one was just y, so we are done.